About 50% of all the money that we spend on heating and cooling costs is due to inefficiencies in the way these systems are installed. In fact, about 25% of that is through leaks in the ductwork, and the other half is in the units themselves. With me is John Proctor from Proctor Engineering Group. And John, how these units are installed has a lot to do with how efficient they are. What do we want to look for?
Yeah, absolutely. Well, the biggest problem is that the vast majority of them are installed wrong. Basically, a standard installation involves setting the outside unit, bringing a set of lines out, brazing it together, opening the valves, turning it on, and seeing if you get cold air. Now, that just doesn't make it. What you really need on a proper installation is, first of all, you have to match the outside unit and the inside coil. Second thing you have to do is you have to braze the lines using nitrogen. So when you flow nitrogen through it, you don't get little pieces of carbon that'll end up clogging the unit and making it not work right. Next thing you have to do is you have to evacuate the lines in the inside coil. So you need to use a vacuum pump, you need to use a micron gauge, you need to pull all the moisture and air out of those lines in that inside coil before you put the refrigerant in. Then the next thing you have to do is release the refrigerant into the inside coil and the lines, and then you have to check to make sure you've got the right amount, because this comes with a certain amount, but it's not the right amount necessarily for your inside coil or the length of the lines that you actually have. So you usually have to add enough refrigerant to get it up to the right amount of refrigerant in order to have the unit run at its top efficiency.
What about ductwork installation?
Well, ductwork, of course, is a big part, just as you said at the beginning. Having leaky ductwork, I mean, this is a really high efficiency unit we're looking at here, probably a SEER 14 unit. Now, if it's hooked into a standard leaky duct system, you might then be talking about SEER 10. And if you put the wrong amount of refrigerant in, maybe you're talking about SEER 8. And if you get the wrong amount of airflow, maybe you're talking about SEER 7. So you just bought a 14 and you got a 7.
Doesn't sound very efficient.
No, that's a horrible idea.
John, what about airflow? That's pretty important in terms of the system's overall efficiency.
Absolutely. The amount of airflow across the inside coil is really essential, particularly in hot, dry climates like California. And so what you have to do is not just take the word of the manufacturer that, oh, this is a 4-ton air handler or something like that. If you take a 4-ton air handler and you put it on a tiny little duct system, you're not going to get enough airflow. So you really need to test it. There's a couple of different ways of testing it. There's a temperature split method, which is a real common method. It's easy to do. What you do is you measure the wet bulb and dry bulb temperatures. That tells you what the humidity is, as well as the temperature on the return side, and also what the temperature is on the supply side. So you see how much the temperatures drop between the return and the supply. And based on that temperature drop, you can tell whether or not you've got too little airflow or not.
Where do you go to find that information out?
You compare it to a table which you can get at the CEC website. It's good for all the states, it's good for any place. It's good for Saudi Arabia, it's good for the East Coast, you name it. So you go on the website, you see what the amount of temperature split should be, and if it's too high, if your temperature split is too high, then you've got too low airflow.
Other than the temperature split method, is there another way to measure airflow?
Well, another way is with the flow grid, which is a new device which you actually put in where the filter would normally be. You take a few pressure measurements, and from that you can get a real accurate measure of how much air is flowing through the inside coil. It's a really excellent way to do it.
How do you know if you got the proper amount of airflow? Do you look at the manufacturer's specs?
Manufacturers actually have a variety of specifications for different places. So for example, if you're in Atlanta, Georgia, and it's really hot and humid, then you may want to have 350 CFM across the inside coil per ton. And like out here in California, probably 450 CFM per ton across the coil.
What about the size of the line set itself? Sometimes it seems like they run some awful long line sets.
Yes, as the line set gets longer, you have to change the diameter of the line set. And again, that's something that all the manufacturers specify, but is most often ignored. In fact, one of the things that you often find is that coming out of the back of the unit, they'll actually use a smaller line set than was even designed for in the first place. And I've actually seen people just take clamps and clamp down, squeeze down the unit, not even put a fitting in there, and then braze it over that leak. So it's pretty amazing what you see.
What does that do to efficiency?
Well, the efficiency drops way off because you have a good pressure drop going through there, and nothing's working right at that point.
John, if we look at the hits that we take in efficiency on the installation of these units, what are they?
Well, you're taking a hit when you don't evacuate the system, because what you end up with is air and moisture in the system. You're taking a hit when you don't have the right amount of refrigerant in the system, taking a hit when you have the wrong amount of airflow, when you have low airflow across the inside coil. You're taking a hit not only as far as efficiency goes, but you're also durability. So, for example, when you don't evacuate the system and leave moisture in there, so the result of that is that it'll turn to acid inside the system and it actually corrode your system from the inside. You have the wrong amount of refrigerant, then you may have too much superheat, which means that the compressor will overheat and burn out. If you have too much refrigerant, then it's going to slug liquid back to the compressor and ruin the compressor that way. So the durability of the system depends upon you doing it right. And that's something that builders really get stuck on, and HVAC contractors as well. So if you don't do it right the first time, it's going to keep coming back and biting you.
How do we verify to make sure all these things are done right? If I'm a builder, where do I go?
One of the first things is make sure that they know what the specifications are. But then you need some way of having that information come back and get checked by somebody pretty independent. That helps everybody out. It helps out the builder, helps out the state, and it helps out the HVAC contractor. It's going to have a callback.
John, a lot of these problems could be prevented with good training. Where does an HVAC contractor send his people to get good training?
Well, there's a lot of trade schools, and of course all the manufacturers have training. What we found is the most important thing is to go out with individual technicians into the field and work with them on the units that they actually work on. That's the only way that they really completely understand it, is if you're out there hand in hand with them going over the stuff. At that point, you got good training, you got technicians who know what they're doing.
John, great information.
Okay, thank you.